Children, now let us start the new chapter, friction. What is friction? To understand this, you do one activity. Gently push a book on a table as shown in the figure. You observe that it stops after moving for some distance. Here, if you push a book, initially it was here, and if you push it, it moves some distance and stops. Repeat this activity pushing the book from the opposite direction. Here you push the book from the opposite direction. Does the book stop this time? Can you think of an explanation? Can we say that force must be acting on the book opposing its motion? Here, if you push the book in this direction, it moves little distance and stops. Again, if you push the book in this direction, in this situation also, it moves some distance and stops. And what is the reason for this? Here, there must be some force to stop the movement of the book. What is that force? This force is nothing but force of friction. Here, the force which acts on the book to oppose its motion is called force of friction. And also you know that driver of a car or a truck slowing down the vehicle at a traffic signal, you too slow down your bicycle whenever needed by applying brakes. Have you ever thought why a vehicle slows down when brakes are applied? Not only vehicles, any object moving over the surface of another object slows down when no external force is applied on it. Here, when the vehicles are moving on the road, there is a force, frictional force between the surface of the road and the vehicle's tire. And when the brakes is applied, here the vehicle stops due to the frictional force. In this situation, force is applied on a book to move it, but it stops. Here, friction opposes relative motion between the surfaces of the book and the table, which makes to stop the book. So, in each and every cases, there is a frictional force between the two objects which are in contact with each other. A boy falls down when he steps on a banana peel. Why do we slip when step on a banana peel? Why is it difficult to walk on a smooth and wet floor? You will find the answer to such questions in this chapter. In this activity of pushing the book, you can observe that if you apply the force along the left, friction acts along the right. If you apply the force along the right, the friction acts along the left direction. In both the cases, the force opposes the motion of the book. In both the cases, friction or the force opposes the motion of the book. The force of friction always opposes the applied force. Here, the frictional force or force of friction is in the direction of the opposite to the applied force. In the opposite direction of the applied force. In this activity, the force of frictions acts between the surface of the book and the surface of the table. Here, the force of friction acts between the surface of the, that is the lower surface of the book is in contact with the surface of the table, and there is a frictional force is between the surface of the book and the surface of the table, and the frictional force is not same for all the surfaces. It depends upon the smoothness or roughness of the surfaces. Children, let us find the factors affecting friction, and now let us discuss about the spring balance. So what is spring balance? It is a device used for measuring the force acting on any object, and also it is used to find the weight of the object. It consists of a coiled spring. Here there is a coiled spring which gets stretched when a force is applied to it. If the force is or weight is kept on the lower portion of this hook, it will get stretched. Stretching of the spring is measured by the pointer moving on a graduated scale. Here is a graduated scale, and here is a pointer. It is a pointer, and the stretching of the spring is measured by a pointer moving on a graduated scale. The reading on the scale gives the magnitude of the force. Reading on the scale, here there is a scale for reading, and the pointer moves and reaches some reading, and that is the reading which is the force applied, or that is the reading which gives the weight of the object. Children, observe the movement of the pointer when weight is kept on the hook. See, as the weight increases, the indicator shows more force, more weight. Now, let us perform one activity. Take a string around a brick. You take a string here. Pull the brick by a spring balance. Here there is a spring balance, and connect the brick and the spring balance by the string, and pull the brick by a spring balance. Here, by using the spring, you move it. Here, the brick can be made to move by pulling it by using the spring. You need to apply some force and note down the reading on the spring balance. Here, note down the reading on the spring balance when the brick just begins to move. When we have to note down the reading here by applying the force, the brick starts to move. When the brick starts to move, then we have to note down the reading in the spring balance. It gives a measure of the force of friction between the surface of the brick and the floor. Here, you know that the brick is on the floor, and there is a frictional force between the floor and the brick, and the reading in the spring balance gives the force of friction between the surface of the brick and the floor. Here, what you have done, see a string here. It is tied between the spring balance and the brick, and when the force is applied, or if we pull the brick by spring balance, and the amount of force applied on the brick can be measured with the help of the pointer which is moving on the graduated scale, and when the brick starts to move, then we have to note down the reading in the spring balance, and that reading gives the amount of frictional force between the brick and the floor. Here brick and floor are in contact with each other, so between that two surfaces there is a frictional force, and that frictional force can be measured by using the spring balance. And now wrap a piece of polythene around the brick and repeat the activity. Here what you have to do, wrap a piece of polythene around the brick here. Here you cover the brick with the here in between the contact. Here you wrap the piece of polythene around the brick and repeat the activity. And what do you observe here? Is there any difference in the reading of the spring balance? What might be the reason here? What happens? Here there is a smoothness of the contact increases. As the smoothness increases, the spring balance shows the decrease in the reading. And repeat this activity by wrapping a piece of jute bag. In the third time, here you wrap the piece of jute bag around the brick, and again you observe the reading in the spring balance, and again you can note the difference in the force applied. And here in three cases there is a different amount of force applied, and means in three cases the frictional force is different. Children, you do one more activity. Make an inclined plane on a smooth floor on a table. Here there is an inclined plane. You can make it on a floor or on a table. Here use the smooth floor or use the table whose surface is smooth. You may use wooden board supported by a bricks or books. To make a inclined plane, you can use the set of books or set of bricks. And put a mark with a pen at any point on the inclined plane. Here you put a mark. Here by using the pen, put a mark A or any mark on the inclined plane. Now let a pencil cell move down from this point. Here you must leave the pencil cell move down from this point, that is from the point A. How far does it move on the table before coming to rest? That you have to note down. Here note down how far does it move on the table before coming to rest. Here it is left from the point A and reaches certain distance from the inclined plane and comes to rest, and note down the distance. Now spread a piece of cloth. Spread a piece of cloth over the table. Make sure that there are no wrinkles on the cloth. Here cloth must have no wrinkles. And try this again. Here try the same activity. Do the same activity again. Again read the cell from this point, and again you note down the distance traveled by the pen torch. Note down the distance here. In the first case, here it reaches this point, and in the second case it reaches this point. So here what you can observe, the distance traveled decreased. Here when there is no any cloth or anything on the table, and it travels on the table and reaches this distance, and here it travels on the cloth and reaches this distance. Again you repeat this activity by spreading a thin layer of sand over the table. Here you remove this cloth and spread thin layer of sand over the table. Maintain the same slope throughout the activity. Again you note down the distance traveled by the object when it is led from the point A. And note down in which case the distance covered is minimum, in which case the distance covered is maximum. Why the distance covered by the pencil cell different every time? Here The reason is that the distance covered depends upon the nature of the surface on which the cell moves. In the first case, the cell moves on the table. In the second case, cell moves on the cloth. And in the third case, cell moves on the sand. So here what you can observe, the smoothness of the rough surface of the cell, also affect the distance traveled by the cell, and also smoothness of the other surface on which it travels, that also depends. So friction is caused by the irregularities on the two surfaces in contact. Even though surfaces which appears very smooth have a large number of minute irregularities. Irregularities on two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. Here, if you consider the cell and the surface on which moves, the distance traveled by the cell depends upon the smoothness of the surface of this on which it travels and also its smoothness. So, irregularities on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surface, there are a larger number of irregularities, so the force of friction is greater if a rough surface is involved. In the case of sand, you know that there are large number of irregularities. But here, in the case of table without having cloth and sand, there is less number of irregularities. So, on the rough surface, the force of friction is greater. And the friction is caused by the interlocking of the irregularities in the two surfaces. Here, the surface of the cell and the surface of the table, cloth or sand. And the force of friction will increase if the two surfaces are pressed harder. And we can experience it by dragging a mat when nobody is sitting on it and when a person is sitting on it. In the case of book and table, the surface irregularity can be observed here. Here the upper portion is a surface of a book and the lower surface is the surface of the table. And this is the surface irregularities. Here you can observe the surface irregularities, and rougher surfaces have more friction between them than smoother surfaces. Why friction occurs? Friction occurs because no surface is perfectly smooth. No surface is perfectly smooth. Even surfaces that look smooth to the unaided eye may look rough or bumpy when viewed under a microscope. Here, they look lumpy or rough when we viewed under a microscope. And if you look at the metal surface, they are very shiny to look. But when highly magnified, the surface of metal appears to be very bumpy. Therefore, here you know that rougher surfaces have more friction between them than smoother surfaces. Children, please note down the points. First you write, what is friction? What is friction? Friction is a force that opposes motion between any surfaces that are touching. So what is friction? Friction is a force that opposes motion between any surfaces that are touching. Examples for friction. Examples for friction. Friction between graphite in a pencil and a sheet of paper. Friction between graphite in a pencil and a sheet of paper leaves mark on the paper. Friction between graphite in a pencil and a sheet of paper leaves mark on the paper. Moving ball on the ground, stopping after some time. Why friction occurs? Friction occurs due to the roughness, weight of the surface, pressing between the surfaces. Why friction occurs? Due to the roughness, weight of the surface, pressing between the surfaces. We know that no surface is perfectly smooth. Even surfaces that look smooth to the unaided eye make look rough or bumpy when viewed under microscope. Here, even the surfaces that look smooth to the naked eye may look rough or bumpy when viewed under microscope. What are the factors that affect friction? Roughness or smoothness of the surface, area of the touching surface, weight of the object, hardness of the pressing between the touching surfaces. Here, as the roughness of the surfaces increases, the friction also increases. Friction between the object also increases. As the roughness of the object increases, friction between them also increases. And the area of the surface, area of the touching surface, touching area of the surface increases. As the area of the touching surface increases, the friction also increases. As the weight of the object increases, then also friction increases. Here, if a body with more weight moves on a surface, then there is a cause of more friction. Hardness of the pressing between the touching surfaces also affect the friction. As the hardness of the pressing between the touching surfaces increases, the friction also increases. In this way, these are the factors affecting the friction. We know that rougher surfaces have more friction between them than smoother surfaces. Rougher surfaces are having more friction between them than smoother surfaces. So you can clarify that the friction depends upon the roughness or smoothness of the surfaces. That is why we put sand on icy sidewalk and roads. And increasing the area of surface that are touching also increases the friction between them. As the area of touching increases, the friction also increases. That is why you can't slide as far across ice with shoes as you can on the thin blades of skates. Here, as the area of the touching surfaces increases, friction increases. That is why you can't slide as far across ice with shoes as you can on the thin blades of skates. The greater surface area of the soles of the shoes cause more friction and slow you down. Here, we can give the example that the greater surface area of the soles of the shoes cause more friction and slow you down. And also, heavier objects also have more friction. Why heavier objects? press together with greater force, and this causes greater friction between them. Therefore, you can say that hardness of the pressing between the touching surfaces also increases the friction. As the hardness of the pressing between the touching surfaces increases, the friction between the touching surfaces increases. In this way, you can clarify that these are the factors affecting the friction. Then, what are the effects of friction? The main effect of frictions are: friction opposes the motion of the object. You know that here moving ball on the ground slows down after some time. That is because of friction. And friction produces heat. How the friction produces heat? Here if you rub your palms, your palm becomes hot. That is, you know that friction produces heat. That is why rubbing your hands together makes them warmer. But do you know why friction causes the molecules on rubbing surfaces to move faster? So they have more energy. This gives them a higher temperature and they feel warmer.